Hello students, in today's video, we are going to explain some numericals based on first chapter of 11th chemistry, which is basic concepts of chemistry. So in your exercise, there is one numerical, which one of the following has maximum number of molecules? So this is your question and you have given four options. Option A, 7 gram nitrogen. Option B, 2 grams of hydrogen. Option C, 8 gram oxygen, and option D, 20 gram of NO2. Okay, so these are the four options, and from these four options you have to choose one option which has maximum number of molecules. Now look very clearly that here it is given number of molecules. So we have two formulas with us. Okay, so the formulas are in the chapter only. First formula, which is number of moles, which is about number of moles. So the formula is weight given divided by molecular weight. So this is the formula. Okay, weight given divided by molecular weight. So this is about number of moles, to calculate number of moles. And the second very important formula, that is number of molecules that we have asked. Number of molecules, which is number of moles multiplied by Avogadro's number. So these are the two formula we will need while solving this numerical. Now, number of moles, definitely we will get a value and the unit will be mole. That will be number of moles. And to convert them into molecules, we will need this formula, which is number of moles into Avogadro's number. Avogadro number is denoted by capital Na, and the value of Avogadro's number is always constant, which is 6.023 into 10 raised to 23. Okay, so this is very constant value and you have to keep in mind this value, which is Avogadro number, or it is called as Avogadro's constant, and number of moles that you will use from this. Now we will go further. We will check it one by one. That is, we will go with option. So option first is 7 gram nitrogen. We will check for it. We will go to another page. So first is 7 gram of N2. So weight given, that is 7, divided by molecular weight of nitrogen, that is 1 nitrogen 14, but there is N2, so it will be 28. So nitrogen is having 28 molecular weight, which is 1 by 4, which is nothing but 0.25, and 0.25 are what? Number of moles. And you have to calculate number of molecules. We will calculate it further. Number of molecules is equal to number of moles, that is 0.25 into 6.023 into 10 raised to 23. So after you will get number of what? Molecules. Don't get confused between moles and molecules. So if we multiplied now the 0.25 into this Avogadro number or Avogadro constant, we will get a value which is somewhere around 1.50 into 10 raised to 23. You can check it on calculator as well as, and also from the log table. So 1.50 into 10 raised to 23 are the number of molecules that we get from 7 grams of nitrogen. Next, we will go to second option, which is 2 gram of H2. Okay, 2 gram of H2. Again, given weight or weight given, that is 2, divided by 1 hydrogen molecular weight is 1. So here there are 2, which means molecular weight is 2, which is equal to 1. So 1 are what? Number of mole, 1 mole. And what about molecules now? 1 into 6.023 into 10 raised to 23, which is again the Avogadro number. You are multiplying this value by 1. So answer will be 6.023 into 10 raised to 23. Now they will be molecules. So in first option, your answer is 1.5 into 10 raised to 23 molecules. And in second, you are getting 6.023 into 10 raised to 23 molecules. We will go to next page and we will solve for another two options. Third option, which is 8 grams of oxygen. 8 gram of oxygen. So 8 is the weight given. And what about O2? The molecular weight is 32. Why 32? Because molecular weight of one oxygen is 16. There are two oxygens, which is 32. So 8 by 32 is again 1 by 4. Okay, which is again 0.25 number of moles. And if we multiplied 0.25 into 6.023 into 10 raised to 23, you will again get the same value as option number 1, which is 1.50 into 10 raised to 23 molecules. Okay. And last option, which is 20 grams of NO2. 20 gram of NO2. So weight given is 20 divided by, if I have to calculate the molecular weight of NO2, nitrogen is 14, one oxygen is 16, and there are two oxygens. So 32, which is nothing but 46. Okay. So 20 divided by 46, if you go by log table or by calculator, you will get something, so I can simplify, it's 10 by 23, which is nothing but 0.43. Okay. And these are number of moles. And again, if we calculate 0.43 into 6.023 into 10 raised to 23, you will get value which is nearly equal to something like 2.589, something like that, which are molecules. So in fourth option, you are getting 2.58. Okay, you can say it is 2.6 by rounding off. In option 3, we are getting 1.5. If we go to again page 2, we are getting 2 gram of H2, which is the highest. See, 6.023 into 10 raised to 23 molecules. And in again option number 1, here we are getting 1.50 into 10 raised to 23 molecules. So which one is the highest number of molecules? So your option is 2 grams of H2. We are going to first page. And our option is option B, which is 2 gram of H2. So following maximum number of molecules is 2 gram of H2. Very important formulae are number of moles is nothing but weight given divided by molecular weight. And secondly, number of molecules is equal to number of moles into Avogadro's number, which is constant 6.02 into 23 into 10 raised to 23. Okay. Thank you.